All right, folks. So again, we updated a couple things on graphing tangent functions. Everything we talked about on the top of the page totally applies. Everything is the same. The parent function is exactly the same. The only difference is here in our general formula for the tangent function, we got to change that to be minus, just like the sine and the cosine. And that was my error, and I'm sorry about that. The other thing was the horizontal shift. We can keep it as positive c over b instead of negative c over b. And I'm going to add one other thing here. And the period, we're going to take the absolute value of b, which it's going to be obvious because you can't have a negative length, but this is b, and we're going to take the absolute value of it. Okay, those are the three changes. So going over them again. In fact, I'll put another mark for this. Just double check that you have everything that has arrowed. Make sure that it looks like that. Okay, and like I said, the tangent function, this is the parent function. There's no transformation, movement, up or down, compression or squeeze or anything. The parent function always goes through the origin, right? It comes up from the left and continues up to the right, and it goes right up against these asymptotes. Okay, these asymptotes. Now, the one difference between sine, cosine, and now our tangent function was the window, and really what we're looking at, the period we're looking at, is a distance here of pi. Remember, before it was 2 pi divided by b. Now it's just pi divided by b. So each of these in our parent function, at least, our parent function has a period of pi, because this is negative pi over 2. That distance to 0 is pi over 2. Then 0 to pi over 2 is another half of pi. So together, these two halves make one entire pi. Okay, so the parent function, I want you to think of it as we are only, when we're doing these examples, we're doing them in respect to the parent function. So if this entire parent function was, instead of tangent of theta, it was tangent of theta plus 1, right? The asymptotes wouldn't change. The asymptotes wouldn't change because there's nothing going on with frequency and phase shift and all that. But the d value, if it was plus 1, everything would be moved up. It'd be moved up 1, okay? So instead of at 0, 0, it would be at 0, 1. Okay, so if you have a vertical shift, you're just moving it up and down. We looked at the tangent graphs in Desmos last time. But that's really what we're doing. We want to think of, how is the parent function changing? How is the parent function changing? And that may mean for our window of pi where we're looking, it might mean that there's a frequency of 2 where there's 1 and then another 1. Okay, it could be a frequency of 3 where it's 1, 2, and 3. Okay, we want to show that window of pi length, just like with the sine and cosine we saw that we showed it for 2 pi. But tangent is in respect to pi, and that had somewhat what we were looking at here, where we had the undefined. Right, it's related to that. It's related to that as far as halfway around the circle is pi. And that's where we always find our undefined lines. So the tangent function is just kind of compressed between our asymptotes, and that's related to where it's undefined. Okay, so I want you to keep all this in mind. Let's go ahead and try to graph this. Let's graph the tangent of 2x. So let's go ahead and rewrite that. So in our last example, remind me in the chat, did we do example 1 and 2? You guys have that in your page? What do we have from last time? What was it? 1 and 2? It actually, either or, it won't matter. I want us to start. We only did 1. Let's start even with 1. Let's do 1 again. Okay. So we're looking here, the tangent of 2x, and we're going to go ahead and make our graph right here. Now I'm not going to put anything on the graph other than 1 and -1 to start. Those are important numbers as far as our y-axis goes. The x-axis is going to denote going around the unit circle, just like we've been doing with sine. So, eventually we'll put, pi over 2, pi, 3 pi over 2, 2 pi, and in the other direction if needed. But now I want to look at this, and I want to compare it to this up here. Compare it to this up here. It looks a little bright. Not better? So let's just put our values here. A, what's in front of tangent is 1. Okay. Our B value, which is our frequency, it's in front of theta, in this case x, denoted our unknown. So we're going to go our B value is 2. Okay, that's going to help us find our period. But let's go ahead and put our C value, our phase shift, is 0, because it's 2x minus 0 instead of minus C. There's no C value, so we'll say it's 0. And D is also 0. Okay. So remember that let's start at the top. A is the amplitude, so because the amplitude is positive, I'm just going to make a little note here that's positive. Okay, it's positive. Now, when we get to our frequency, which is B, what this is saying is that there's going to be 2 repeats within our frame of pi, within a frame of the distance of pi. So that tells me that the frequency is 2, so what I'm going to do is find the period. And the period is going to be what? Pi divided by 2. Pi divided by 2. And pi divided by 2 is pi over 2. Okay? So what this is saying, remember our period is the time it takes to repeat. So this is, I'll say, 1 cycle. Okay? The period is 1 cycle. Now we know we're going to look at a window of pi, from negative 2 pi over 2 to positive 2, negative pi over 2 to positive pi over 2. But it looks like the period is actually pi over 2. So we're going to end up with a slimmer one here in the middle, and then we're going to have to put another one on the side next to it. You'll see. All right, let's do horizontal shift. We have the horizontal shift, which since C is 0, the horizontal shift is C over B, so 0 over 2. Horizontal shift is 0. Okay, so no shift. No shift. Whoops, no horizontal shift. Probably good to have all this down. All right, so we have our period. We have our horizontal shift. Now let's do the vertical shift. Vertical shift is 0, so we have no, let's circle that 0, no vertical shift. Okay. Now, with every single function, this is how I teach it. I teach all of graphing functions from the parent function. Because remember, like I said, if we had tangent of theta plus 1, right? Plus 1, if D was 1, then instead of going through the origin, everything would be moved up. So it would go through 0, 1. It would be up here instead. The whole thing would be moved up. Okay. So we got to keep in mind that because this graph here does not have a horizontal shift. It does not have a vertical shift. So it's matching my parent function. There's no shift from where it usually is. It's going to be right there at the origin. Okay. So remember, if you're looking for the vertical and horizontal shift, if we do not have any horizontal shift or vertical shift, that means that it's matching what the parent function is. It's going to go right through the origin. If we had a vertical shift that was -1, the whole thing would be moved down -1. But we don't. We have no horizontal, no vertical. So we're going to keep this at 0, 0. Okay? Now, the part about this, here we go. The period is pi over 2. And what that is saying is the repeat, the full cycle, wherever this goes through, right? We know it's going to look like this. And what that's saying is that it takes pi over 2 to repeat. But we're starting in the middle. Essentially, we're starting right here, right? We're starting in the middle. So if my period is pi over 2, I have to think about it and say, well, I know that as I go from this inflection point, our main point here, it's going to go out, and the full distance between my fingers here is going to be pi over 2. So you always find where that middle point is based on the horizontal shift and the vertical shift. That's right here. You know your period is pi over 2, so that means that as I open my fingers to show where the asymptotes are, they're going to be, the distance between my fingers here is pi over 2. Okay, that's how wide the function is going to be. This point here is just the point in the middle. Okay, so if this whole distance is pi over 2, maybe getting out a unit circle, that might even be helpful to look at it and say, well, I know that pi over 2 is here. What's halfway? What's half of pi over 2? Half of pi over 2? Pi over 4. Right? Halfway between 0 and pi over 2, halfway is pi over 4. So that's one thing that we can bring into that. You can also just say, well, I'm going to just do it this way. Pi over 2 divided by 2, right? I'm dividing in 2. Oops. Essentially, I'm dividing by 2 over 1. I'm dividing in 2 so I can see, well, where is going to be, how far over do I need to go? How far over do I need to go? And what we end up with is pi over 2 times 1/2. Remember, we do that little flip trick. That gives us pi over 4. Okay, that's one way to work it out. So what I know about this is, for one, let's start over. Horizontal shift, vertical shift, I figured out from my details here, 0 and 0. There's no horizontal or vertical, so I know it goes to the origin. I then found the frequency was 2, and we find the period, the cycle, how long it takes for one cycle by taking pi and dividing it by the frequency. So pi over 2 is how long it takes to do a full cycle. And now if I know this point, what I need to figure out is really how far over from that point in both directions where am I going to find those asymptotes? Okay. So I've done all that work. I've done a lot of work already. And I know that it's going to be moving over pi over 4 and moving over pi over 4 because pi over 4 plus pi over 4 gives us our pi over 2. Okay. So it's all a matter of find where the point is. Find the period. Divide the period in half, and that's how far out you move to get to your asymptotes. Okay. So let's do that. Let's move over, and I'm going to put, I'll make it 4. I'm going to spread this one out. No, let's make it 2. All right, so here's negative pi over 2. Here's positive pi over 2. What am I doing? Negative pi over 4, positive pi over 4. At least I caught it quick. Mistake city. All right. Because we had to go this direction, right? We had to go in this direction and that direction. That same amount that we figured out. Okay. So now that's where I'm going to put my asymptotes. There's a joke in there. I'll get it. All right, we got our asymptotes. Yay. All right. So now I'm going to go ahead and make some marks halfway because essentially we're breaking this into 4 different segments. There's the segment where it's coming up from the asymptote. There's a segment between the halfway point is another segment between the halfway point and our inflection point. The inflection point to the other halfway point, and then going towards the asymptote on the other side. So what we know is, since there's been no shift, our A is 1 and it's positive, we can just go ahead and basically make this go down through -1. And halfway through, I'm going to go through +1. We're not studying the compressions as much. So we're basically, we're almost done here. We don't have to consider too much what's happening at these points for now. Okay, so here's the thing. I need to show a little bit more than this. I've only shown how much is my window here. I've only shown pi over 2. I need to show a little bit more, okay? I need to show another repeat over here, another period, another cycle. Because I always need to show a window of, how many? 4, 8. I always have to show a window of pi, okay? So I'm going to go ahead. I know I could see that my next asymptote, just because I've done it this way, 1, 2, 3, 4 boxes. So I'm going to go another 4. 1, 2, 3, 4. I'm going to put my dash line there. And then I'm going to figure out what is that radian value. Because I know what I was looking at is this period over here. One cycle was pi over 2. So this period over here has to be pi over 2. Right? So now my question is, what is this point? What is my radian measure right here where the other asymptote is? How are we going to find that? How are we going to find that? Essentially, I have to figure out how to measure from my y-axis over to see where that asymptote is. So what can we do? What should we do? See, my thought is we take this. We know this distance is pi over 4, right? We know this distance is pi over 4. So I know that I had to go another pi over 2 further. So if I add pi over 4 and pi over 2, that's going to get me that value over there. And then we'll be able to mark it and do our next one. So I'm going to take pi over 4, and I'm just finding my next asymptote by adding pi over 2 to it. Why? Because I know each cycle is pi over 2. This distance was pi over 2. So to find the next asymptote and have my next cycle, I have to go another pi over 2. So I go over from the y-axis, pi over 4, and then I have to go another pi over 2 and figure out what that's going to be. So I'm going to go ahead and make a common denominator. Pi over 2 is 2/4. And how much is that? 3 pi over 4. Yeah, that makes sense. Okay, because that's 1. All right, so we know that this is at 3 pi over 4. Excellent, excellent. And now we just have to do the same thing. We have to go and know and see that the inflection point's in the middle. It's going to be down 1 halfway, up 1 halfway, and go ahead and make your next cycle. Okay. So here I only had to graph 2 of them. Because I need to show 1 whole pi worth of the window. These continue. They're going to keep repeating forever in both directions in that same increment. Pi over 2, pi over 2, pi over 2, pi over 2, pi over 2. That's the period of it. If my frequency was like 10 and I end up with pi over 10, then I'd have to show 10 of these things. Oh God, don't give us that problem, please. Okay. We're going to keep going. We're going to keep working on these graphs. Let's go ahead and try the next one right below it. Okay. The next one has some different aspects to it as well. Let's see. Y is equal to tangent. Let's do x minus pi over 2. I'm glad I only did example 1, didn't try to push through this. All right, let's go ahead and find A. What's A? What's A? A's 1. A's 1. 1, it's positive. That's going to help me remember if it's flipped or not, if it goes up to the right or if it goes down to the right. If it was negative, it would be flipped. It wouldn't come up, it would come down. Okay. So I'm always referencing my equation over here, my equation. And let me zoom out. So I found A. A was 1. It's out in front. Okay. Now, what is my B value? What is my frequency? Frequency, we always find that in front of X or theta, are unknown in the parentheses here. And what's in front of X? Another 1. So my frequency is 1. That's going to make this a quicker problem. All right, let's see if we have any horizontal shift. C is right here. And I look at, since I corrected this and made it correct for you guys, remember that the general equation for the tangent function is bx minus c. So the c value here, since it's minus pi over 2, c is equal to pi over 2. Okay. Let's see about D. Do we have any horizontal shift? Or excuse me, vertical shift. So this is the horizontal shift. This is vertical. And what is it? It's all of this plus 0. It doesn't have any number out by itself. It just has this expression and then it ends, so we know it's 0. So this has no vertical shift. It's good to know. Get that in your mind. All right. And let's go back up to the top. I just did this one because when it's 0, I like to just put the things that I've done already here. We know that the frequency was 1. So remember that tells me and gives me information for my period. The period is going to be pi over b, which is 1. So my period is pi. Hey, that's nice because that's the window that I have to show anyway. That's the window I have to show anyway. All right, and then let's find our horizontal shift. To do so, we take our C value and divide it by B. C divided by B, we're going to go right here. C divided by B is pi over 2 divided by 1. That's just pi over 2. Okay. So we also have our horizontal shift. Positive pi over 2. Okay. Now let's go over here and get ready to graph it. All right. So I'm going to go ahead and put 1 and -1 in there. And then I want to think about this for a second because, again, it's always related to the parent function. The parent function has that inflection point. Inflection just means where it changes from going curving. It's like the curvature. It's in between it curving this way and that way. There's a point where it's not going anyway. It's kind of like in between right here. Okay. So the inflection point right here is at 0, 0. But that's if we have no horizontal shift. Since we have a horizontal shift, what I'm going to do is I'm going to put right here pi over 2. And I'm going to say, well, I don't have any vertical shift. It doesn't go up and down, so it's, it doesn't move it up or down, but it does move it positive pi over 2. So this is that inflection point. You see, you always find where that point is, and then you're going to use the period to move out in both directions to find your asymptotes. That's the most direct way. And you might watch videos, if you look online, you might watch videos that teach it a different way. There's a bunch of ways to approach it. This is a good math 3 approach. You may learn more in pre-calculus or in calculus. Okay, there's all kinds of ways to do everything. You're like, dang it, I need one way. That's okay, don't worry. All right, look, we did the horizontal shift. Actually, we did the vertical. We know there's no vertical. We know the horizontal shift. Now we know where we're starting. So really, A was 1. It's positive, so I know it's going to come up from the left up to the right, so left to right. It's going to be that same shape. But now we need to figure out, okay, if my period is pi, what that's saying is, right? What that's saying is wherever my asymptotes end up, the distance between the asymptotes, the cycle, is pi, right? That's ugly graph. Ugly. That's getting better, all right? So we know that the cycle, the period is pi. So what we have to do is we have to think, well, I have to go from this inflection point and go to the left and right so that I'm equal distance from each other, and that distance between my fingers is pi. Okay. So I go from my inflection point both directions, and then the maximum distance between my fingers here is going to be pi. That's going to be where our asymptotes are located. So I think about this, since this is, going a distance of pi, how far is it going to be to go halfway? It's going to be pi over 2 and pi over 2. You see? This is just kind of like planning. This down here is just kind of planning to think about it and visualize it, that if I know that the period is pi, then if I'm finding my asymptotes, I have to go this way pi over 2 and that way pi over 2, and that's going to make my distance between the asymptotes pi. That's the main thing. So what do? No vertical, no horizontal shift. Excuse me, no vertical shift. Yes, horizontal shift. Find that place, and then from there, use your period to find how wide you have to open to get your asymptotes. So look what we're going to do. We're going to open up. We're going to go this way pi over 2. We're going to go that way pi over 2. So this point over here, where my right asymptote is going to be at pi. Let's make a dash line there. If I go to the left pi over 2, I end up at my y-axis. So let's put an asymptote there. You kind of see that. All right. And in between, just like with the sine and cosine, you know, we found like these main parts, and then we go halfway in between to see what's happening. So just going halfway in between, kind of right around there, I know that on the left side, right, because it's coming up left to right, left side is going to be down here at -1. Right side is going to be up there, +1. And once you get to this point, you should start to feel good because you're pretty much ready to graph it. Huh. Let's see what we got here. We got a window of pi. That's what we had to show. I'm going to do another one just because it's going to be easy for this. If this width is pi, if I go another pi, I'm going to get right here to 2 pi, and I can make another copy of it. Okay. You have to show a window of pi, so we didn't have to. But this is pretty easy, right? There, -1, +1, make another. This could be like broken record. We just keep going, because it never changes that pattern. It's called periodic function because it just continues. It's one period, then another period, then another period, then another period. Okay. All right, guys, in the chat, let me know in the chat on a scale from 1 to 5, how you feeling about it now after we've done 2 in this kind of manner on a scale from 1 to 5. Give me some feedback, guys, because this is a tricky one. All right, I want to see a couple answers in the chat, please. All right, good. Let's do one last one then, and we'll see how we are. Okay, let's zoom out. All right, thanks for answering, guys. All right, so our last one we had to do is a little more complicated. Y is equal to negative tangent of x minus 2. Actually, that's not so bad. It just has a couple extra things to it. But we've gone through all the elements so far of what you'll have for homework, so I think we're okay. Okay, so remember that we're always relating this, right? Because look, the parent function right here looks like this. It looks like this. Now, comparing, if I cover this up and I cover that up, right? That's the parent function. If I cover up the negative and I cover up this -2, that is the parent function. So essentially what we're doing is we're thinking, how does the parent function move around, up, down, left, right, squeeze in, based on the period. Here the period is pi. What if it was pi over 2? It'd be smaller, right? So we're always thinking, how does the parent function transform? Really, these are transformations of this parent function. So let's look at it. Let's start doing exactly what we've been doing. A is -1. Because this is negative out here, negatory, and it's -1, right? -1. I just like to make a little note there. Hey, it's negative. That's going to tell me that I need to flip it. Instead of going up to the right, it's going to go down to the right. That's all the negative function means. All right, what's my b value? What's my frequency? My frequency here, remember where we find it? We find it in front of our x, or theta in the other case. Let me move this. It's in my way. Oh, I see what's happening. One sec, guys. That's weird. Okay, it's better. All right, so we know that we find the frequency right in front of x, or in this case theta, in this form, how I wrote it. But in this form, we know that our frequency is 1. It's right there. It's what's in front of x? 1. Okay. That's going to help us find the period. C, let's see what our C value is. C is horizontal shift. And I look here, C we always find in the expression that is connected to x, so the tangent of b theta minus c, it would be an expression together, all linked together. And I look here and I see that There's nothing else in this expression. It's just tangent of x. It's not x minus pi. It's nothing else is in there. It has to be in with the x. And it's not. So I know it's 0. So I'm going to put here, it's going to be 0 divided by 1, but it doesn't matter. And if you get 0 for c, there's no horizontal shift. That's helpful. D is talking about vertical shift. And I look here, it's the number out by itself. It is not connected to x or theta. It's out by itself. I look, here it is. It's -2. So what that means is I need to shift this down -2, and that's going to be where my inflection point starts. Okay, so remember, it's all about this. So I can even start to visualize what this is going to look like. Well, one more thing. Whoops. I'm going to do this and find the period. And the period is pi divided by b. Pi divided by b. So I need to go in here and go pi divided by b is 1. Oh, my period is pi again. Yes. All right, and then get ready. Okay, I think we have all the info, so we're going to focus on this now. Okay, so remember, again, it's always relating to the parent function. The parent function goes through the origin 0, 0. So I know since I don't have any horizontal shift, it's not shifting left or right. I know it's going to be somewhere on this y-axis, but I know that my vertical shift is -2. So guess what? I need to make this -1, -2. And that is, I keep writing through my paper today. That's my inflection point at -2. Okay. So we got vertical shift, we got horizontal shift done. Now again, this is where I like to just make a little like note kind of for myself here. I know that this, this is going to go through some inflection point. Whoa, I don't know. Well, I'm going to remember that it's negative. It's going to go like this. It's going to go like that. And I know that the period is how long it takes for one cycle. Remember, the period is one cycle before we start to repeat. So what that tells me is that this is pi. So then if I want to figure out how far to the left and right I need to go to find my asymptotes, I need to divide pi by 2. I need to divide whatever the period is, you're going to divide it by 2. So what that tells me is I have to take pi, I have to divide it by 2. Hey, that's pi over 2. Why did I just write it like that? So I need to go this way, pi over 2. I need to go this way, pi over 2. That's where I'm going to find my asymptotes. Again, there's other ways to do it, but that is, I think altogether, this method is the most straightforward, and it kind of just breaks it down to be a matter of find that inflection point. The period is going to be divided by 2 and go in each direction to find your asymptotes, and then just make your line. Okay, I think we're going to have to put a -3 here as well. Go ahead and put -3 in there. I need to go to the left pi over 2. So I'm going to go ahead and make this -pi over 2. I need to go to the right pi over 2. Pi over 2. And that is the location where I'd find my asymptotes. All right? I guess I got to go a little further down because I forgot it's already down there at -2, so I'll put a couple more. All right. So now we have the middle point. We know the asymptotes, where they are. We need to, I go through and I check things off to help me remember. So I know I just did the frequency period because I know where my asymptotes are. So now we got to go back up here. we got to remember that it's negative. It's negative. So if it's negative, it ends up looking like this. Instead of the parent function going up to the right, a negative just goes down to the right. Is that pretty intuitive? I mean, we had that before. Oh, you didn't learn this from me. But when we had parabolas, some of you did. When we had a was positive, we end up with a happy face. It goes up. Some of you remember this from me. And when a was negative, we end up with a sad face. It went down. You probably didn't learn it that way. I did a bunch of different weird things like that. But it's the same idea that when the a value is negative, it faces down. When it's positive, it goes up. So in the same sense, negative is going to be the opposite of our parent function. It's going to go down. So let's go ahead and remember that we're going to end up with a point right here at -1. We're going to end up with a point down here at -3. And now we can just go ahead and put them in. Okay. That measurement of being up 1 and down 1, and that halfway point, like this is the halfway point between my midpoint and the asymptote. It's always going to be up 1, down 1, unless the a value is different, and that's not something we're going to actually touch on. Maybe next week. I don't know. I don't think it's a standard, but I might want to just teach that to you. I don't think it's a Math 3 standard. Okay, so let's go ahead and just make one other copy. Let's move, let's get one over there. We look here and we have our period of pi, so we need to go another pi over. So that's going to be pi over 2, and we got to go over to the right another pi. So I'm going to do pi over 2 plus pi, which is pi over 2 plus 2 pi over 2 pi. Over 2. And that's going to end up being 3 pi over 2. That's like deja vu of what we just did. So I know this is at 3 pi over 2. That's going to be my next dashed line. Go ahead and just make another copy to the right. Midpoint right there. Up 1 and over and over. Okay. They never touch those asymptotes. They just go closer and closer and closer and closer to it. Yeah. That was good. I think I did it. Yeah. Let me double check what I gave for homework to see if this covers everything. Let me see. Where do I get to it? All right. And then I'm going to zoom out, give you a screenshot, a few different screenshots here. And let me check what I gave you. Minus pi, 4 pi, 3, 4, 2x, 2x. The last one's kind of hard. We might have to do number 4. We might have to do number 4. Sonia, nice. Already done. Sonia, you don't have to resubmit, but I want you to go back in and make sure with the corrections. And you're the one that has to deal with this because you're already done. But these corrections with the arrows that I updated, they're going to affect those problems. Okay. In fact, I'll even let you know they're going to affect. You don't have to redo all those at all. It's going to affect numbers 2 and 4. Okay. So just double check numbers 2 and 4. Make sure you understand how this is going to affect it. That was a typo. And this I just updated a little bit by making absolute value. That's not going to change it. Horizontal shift didn't apply to the other problems. So 2 and 4, Sonia, that's going to help you to update it. You don't have to resubmit. Just look over it. Make sure you got it. All right, let's do a final check-in. I'm going to stop the video. But let's do a final check-in for scale from 1 to 5.